rolling kind of slow, so in case anybody else walks in the room, and we can get going. Hi, everyone. My name is Kim Duarte. I am here I work at Stanford University. I'm a librarian there in sunny California in the United States. I am the manager of our data curation services there, but really primarily for the last 12 years, my main role has been to manage our geospatial data. And so this topic of FAIR principles and curating geospatial data is something, even before they were like codified as an actual set of practices, is something that we've tried to think about in our work, in everybody moving online and all this digital data everywhere. I think it's something that's going to be increasingly more important and will probably evolve in terms of what these principles actually mean. So what are they? FAIR, you've probably all heard about this. We love acronyms. FAIR, findable, accessible, interoperable, and reusable. Since about 2016, I think these were first sort of announced or set in stone in a paper that was published in the journal Scientific Data. There was also a G20 conference that year in China where they really started to focus on people adopting these principles, using these kinds of things, and there was a group of researchers in Australia as well that were really focused on publishing these principles, getting them adopted for research outputs in Australia. Let's see, so just to backtrack a little bit and why this is important to us, where I work is in this place called the Stanford Geospatial Center. It's actually centered in our Earth Sciences library, but we don't serve just Earth Sciences people. We actually do a lot of GIS type things all across the university, different kinds of disciplines. We teach workshops, we do a lot of instruction. We provide GIS, so ArcGIS, QGIS, things like planet.com, satellite imagery. We teach people how to use different kinds of tools, so we teach classes in GDAL and GeoPandas, and just recently we've adopted coursework around like machine learning and stuff like that, because that's obviously came at us pretty quick. The other thing we do is consultation. So we get, just like in any other traditional kind of library, you get these reference questions. We get people coming in asking, how do I find these kinds of data? I've got a grant, I need to publish my data using these FAIR principles, or I need to put my data in a repository. Can you help me? And yes, we can. So we support kind of a broad set of activities within the library, all involving GIS, geospatial stuff. It's kind of fun. My job, or one of the things that we focus on, is geospatial data management. So we collect, because we have this large user community, we collect a lot of data. We either license data from vendors, which is very, very expensive, but also public data, so those things that are produced by governments, which in many cases they're required to put them online. We go and collect those off the web and we store them, we make them available to users, and then increasingly we're getting researchers at the university who are producing their own geospatial data that they need to put somewhere and they need help curating it, describing it, things like that. Excuse me. One of the things that's different, I would say, about a research university versus like a data producer or a publisher is that we have users that maybe want data from 60 years ago, right? Or they're doing land change analysis, population surveys, and things like that. And so often companies or governments that produce data put the latest data set up and then they take last year's down, and I have no idea what happens to that data. So what we try to do in consortial efforts is go and grab really important, what we consider to be high-use public data by our users and actually archive them. And so if somebody wants a parcel data set from 10 years ago, we can get it for them versus having to call the one person that works in GIS at the county that probably has no idea like where that file is. And so that's something as an institution or as an archivally focused institution, we tend to do a lot of that work. In the past, so when I got there, I inherited a situation like this where most of the users had to physically come into the library. You know, they'd have to check out a DVD from the desk, or we'd give them access to this network drive where they'd have to kind of trawl through the files there, find the file that they want based on the file name. Often there was no metadata associated with any of this stuff. If there was, it was pretty sparse, and so they really just, you'd have to look at the file name, say, okay, yeah, I think I want that, and then open it up in a GIS and hope for the best, right? Like there's enough information there that you have something to work with. And so I was brought on with a team of 2 other software engineers to kind of get a better way to make it easier, because no one really comes into the library anymore to look for, some people do, but very few. And increasingly, that's just going to be the expectation, is that this stuff is available online, and it's described in a way where they know what they're looking at. Luckily, when we came into this, we already had an existing piece of infrastructure. The library has a digital repository, and so for us, this is just, we have all kinds of content, images, maps, so like audio, video stuff. So there were certain things that were already in place. We can assign persistent URLs, or what we call PURLs. There's a durable preservation repository that sits behind that. We also have implemented access controls, things like rights management, and so for data that say, or any content that is only available to Stanford, we have the ability to restrict that, or if it's public, we can say, hey, anybody in the world can look at this and download it and do whatever they want with it. And as I mentioned, this is a content agnostic repository, so we put all kinds of stuff in there. One of the things that we decided to do was build on a little bit of functionality that supported geospatial data, because it's not special, but it kind of is special, right? And so there were certain things that we had to do in order to make this work. We stood up something which we loosely call our spatial data infrastructure. This is our digital repository. We have a GeoServer. We have 2 instances of GeoServer. One is public, one is for our restricted data. We use something called GeoBlacklight for our discovery catalog. I'll describe that in a little bit. We also have a geocoding service, which I'm not going to talk that much about today, but it's pretty cool. Okay. All right, so GeoBlacklight. This is something that it's a catalog service for the web discovery. I see Jerome's here. He has GeoNetwork. That's also a perfectly wonderful catalog. Our technology stack relies on something called Blacklight, and so we just, along with 2 other universities, created a plugin for Blacklight, which added some spatial search functionality to that catalog. And so what it does, it's a multi-institutional project. It's open source, and it's all built around better ways to find data and to share data among institutions. Here's our newly designed homepage. At Stanford, we've actually branded our GeoBlacklight instance Earthworks. We've most recently started putting maps in here, as well as geospatial data. Excuse me. And just very quickly, if you're looking for something, say watersheds in India, you've got faceted browsing there on the left. Your map extent will zoom to only what's contained within your search results. One of the other things we do, we're a federated data catalog. So there's now, I started with 3, I think there's about 45 institutions that are now part of this project. And so we can harvest their metadata into our catalog, and particularly with public data, this is a huge advantage, because now we don't have to catalog and put all this public data in our repository that some other institution is already managing. We can grab that metadata and point the users to their servers where their data are being held. So anyway, findability. I think there's 2 major components to this. The first one is digital globally unique identifiers, right? And the second one, the biggest one, is metadata. And so these are the 2 biggest components, I think, to findability in that principle. Data should be described with globally unique persistent identifiers. This is becoming more and more super important. I don't know about outside of research context, but it really should be. Lots and lots of metadata, and then indexing that metadata within a searchable resource, whether that's a geoportal, a generic catalog, or even something like a search engine, or really all 3, if you want. So globally unique and persistent identifiers. The first thing, or one of the things this does, is remove ambiguity from what you're looking at. As data sets maybe proliferate across the web, and they're not really identified with a resource, you don't know if you're looking at the same thing, or you're looking at a different version of something, or something that was taken down. It's very hard to tell. It also allows for both machine readability as well as humans to read and understand what they're looking at, if this is exactly what they want. Facilitates citation. So if you're going to publish a paper or even publish a web map based on somebody else's data, it makes it very easy to say, this is where I got those data, this is exactly the data that I used for my project. And these come in several different forms. DOIs are very common in research environments. Like I said, we use PURLs, but there's ARCs and PIDs or anything else. I don't think it really matters which one you use, but I would suggest at least using one kind. So yeah, Perl, this is just an example of a Perl page. So everything in our repository gets what's called a persistent URL page, meaning that This is a global unique identifier, always at stanford.edu. That identifier, so even if, say, HTTP conventions go away, this alphanumeric identifier within the Stanford ecosystem will always mean something, or it will always be there. Metadata. Okay, I know that no one likes to do this. I know everyone hates making metadata and having to describe things, but it's super important, right? Like it's probably the backbone of any really good discovery environment, or if you want something to be useful. Structured information about the data. Again, it allows for machine and human interpretability. Where we are, use the ISO set of standards just because it's a globally recognized set of standards for geospatial data. I know it's a pain and it's a lot, but there are ways, I think especially now, certain catalogs have templates for this. We use just an automated Python method of creating XML from spreadsheets. It's not like we're creating XML tags and filling things out by hand. It's largely automated at this point, and I think it's much easier than it was, say, like 10 years ago. And so even if you don't use ISO, I would recommend using something that is format or discipline specific for GIS. So maybe it's even like DCAT, or I don't know, an expanded set of Dublin core elements. Just don't use like text files anymore. Or structured data, preferably with a schema that somebody's heard of, right? Or that one other person at least is using. And so this should always contain the data set identifier, link to the data set, and then basic stuff, right? Title, description, spatial and temporal extents. I actually really appreciated the comment in this morning's keynote about temporality, because we think of like spatial as important, where is it? But I think the question of when is also very important. Like data from 2024 is going to be very different than data from 1950. And so I think communicating that to a user, temporal extents are often overlooked, and I think they're super important. Spatial reference systems or projections, and then as well as like attribute descriptions as well in terms of usability or reusability of data. Very important. And I think there's one metadata slide here, but this actually plays into every single principle. I think here it's going to keep coming up, and I know it's hard. So really boring picture here of our ISO metadata, but just to show you titles in this, like don't use the file name. Don't use the file name as a title, right? Just like if it's bridges in Afghanistan from 2001, that's like a great title. It's going to look really nice in search results, right? But if it's just something.shp, anyway, basic descriptions go a long way. And you can see here we've got our identifier there as well as organizational names, provenance, who created this data. Okay, so here is an example of how we federate all of these records from multiple institutions is by distilling down the metadata into a simple set of elements that are geared towards discovery. So we don't index the full ISO metadata into our catalog. We drill it down into, I think, about 10 or 12 elements that are just meant, by looking at this and possibly by inspecting the features on the map, a user can say, yeah, this is exactly what I want, or looks like I want boundaries, state boundaries from Brazil from 2015, and then they can go ahead and download those data. In terms of accessibility, I think this is something that's only going to grow, or you see it, but metadata and data should be retrievable. You should be able to get it some way, right? Click a button and download it or import it into some system. Pretty standard communication protocols here, HTTP, FTP, and then increasingly we're seeing like needs for people to use APIs to get at the data and just bypass, say, downloading it altogether. There's a lot of ways to do this, and so this is something we constantly change based on things that we hear. You could download the entire zip package from our digital stacks and our digital repository. From GeoServer, we do export shapefiles in WGS84. Coordinate system. We switched actually from offering KMZs to CSVs because more people really wanted CSV files, and so that was something we heard, as well as GeoJSON. We also offer access to the ISO metadata in HTML format, and then something we've recently put in, and this was based on one of my colleagues teaches GIS fundamentals, is we've now had like APR programmatic access for these kinds of data. So somebody can take this code right here and like throw it right into a Python notebook or R or something, or leaflet, without having to maybe like open our like call the WFS or something like that. And so for certain data sets, we've started to generate code snippets for some of our vector and our raster files. More options if you want to download files individually. I don't know why you'd want to do that for a shapefile, but if you wanted to. But say you wanted the XML or you wanted just the thumbnail image, you can also get at the data that way. You could also, using those URLs, pull the files directly into a GIS from our digital stacks. And then finally, GeoServer or WFS, WCS. So this has been something I think way before FAIR principles existed. I think OGC has been thinking about this kind of stuff or enabling people to access data using standardized and open protocols. So this is sort of nothing new, but this is one way that users can get at our data. Okay, so interoperable, I think, is also something that we've had to consider and may be likely to change over time. It relies on open standards and open specifications. It calls for data to be integrated with other systems, right? And so you don't want these really old, like, esoteric file formats that you can't open anywhere. Using vocabularies that follow FAIR principles. So this is going to probably largely vary by what kind of environment you work in. I work at a library, so we're sort of beholden to these Library of Congress subject headings, place names, and names. They work great, but we do that so that these resources can co-locate with other items that are in our repository or in our catalog. If you work within a different discipline, you may use like Earth Science Observatory keywords, but I'd say anything that's resolvable at this point would probably be a good choice. And then including references to other resources. So when we get people that come in and they want to create some data or publish data, we usually recommend that they use a file format that other people can use, or they can instantly transform. You see this a lot. Something, you know, maybe you could use GDAL to transform it very quickly, or that any GIS or modern geospatial technology is going to be able to open. So most of these you've probably heard of: shapefile, GeoJSON, GeoPackage, GeoTIFF. We've recently just added support for cloud-optimized GeoTIFFs within our servers, and so usually if people come in, we'll try to recommend them one way or the other, depending on what sorts of data that they're handling. Other kinds of links to resources, usually the GIS data that we get usually comes in collections. So it'll be part of like a 200 something set. And if somebody, say over down there on the bottom left, if somebody wanted to view this entire collection of data, that link will take them to this collection record, and then on the left there they could browse through, say, all 700 of our files here, possibly use the facets to then drill down to another location or another year, something like that. Other kinds of links, so we get a lot of, I guess they're like digital humanities projects where people will take scan maps. They'll take scan maps and they geo-reference them and they want to use them in some modern day analysis, or they'll publish a website. And so what we try to do is include links to scan maps from the geo-reference maps, so that if somebody was trying to backtrack and see how that geo-referencing took place or exactly what map they used, that information is there. Reusable. So this is something I think too is going to sort of evolve depending on how people intend to reuse data. I think right now licensing has become a very big issue. Not having to rely on, every time I want to use a piece of your data, I don't want to have to call you and say, hey, is this okay, right? And so having clear licensing language, even though maybe it's not, nowadays people are using a lot of CC licenses, and that's a link that links nicely in a statement. But even if, in the past they were sort of free text formats to say, you can use this maybe only for educational purposes, non-commercial, something like that. Knowing where the metadata and the data came from, I think, are also pretty crucial to reusability. I'm not just going to go grab some random file off the web and then write my PhD on it, or you maybe want to know where the data came from before you're citing this as authority. So here's some examples of use and reproduction statements that we try to clearly put right in the data. If it's restricted, we'll state that. You'll have to log in. There's like a red thing that you'll have to log in, and you'll be Stanford authenticated through like a Shibboleth application. Otherwise you can't get in. Citation is also really important, especially depending on what kind of research activity you're doing. So we auto-generate citations for all of the data that sit there, including that persistent URL, as well as some of the other information. And so somebody doesn't have to read through Chicago Manual of Style to figure out how exactly to do this. We'll auto-generate that for you. Just two other things, and this is something that people hate this even more than making regular metadata, okay? So feature cataloging, or I guess what we'd call attribute labels and definitions. These are sometimes intuitive, you know, or if something that says like state name, obviously that's probably the name of the state, right? Or you maybe don't need to fill that in. But when we get to certain kinds of data, like we buy a lot of census data, very expensive census data, and you have these labels that is like F_L6, right? Like you're probably not gonna know what that means. And there's hundreds and hundreds of these attributes in a data set. And I think in terms of reusability, this is crucial. Like somebody would have a very hard time using this if they didn't know what any of these labels meant, right? And so often when we buy things like this, we will request that the data vendor give them to us. They always come in a PDF, so we have to take them out. It's kind of a pain. Right now, the format, they only put them in XML, which is kind of uncool, right? But it's structured still. So if somebody wanted to work with this at some point, they could transform it into any format they want. But I would really encourage any of you, especially if you're creating these kinds of data, to supply this information before you send it out somewhere, because somebody like myself is not going to know what that means. And then, you know, the ability for reuse is going to, that value is going to go down. Oh, and then finally, okay, I think this is my last slide. Spatial reference systems. So I can't tell you like how many times you've tried to open up a file and there's no indication of what the spatial reference system is. Invalid, and this makes it very hard, say if we want to serve it into GeoServer and serve it out as WGS84, we have no idea what to transform it from, right? And again, the data producers, are the only ones that know this. I can guess. I've spent a lot of time trying different projections and seeing if I could get it to work. Sometimes it does, but otherwise, something like this, or not including this information, makes it almost completely unusable and very unreliable, I think, in terms of reuse. I think reusability is going to change. It will just change depending on how systems kind of change. We know they will. One of the other things that I think will change greatly is we're having this big push towards digital accessibility, or I guess what's accessibility in the broader term, not in the fair term, where we're having to implement screen readers in our GeoPortal, which is one of the changes that we've just had to make. And I'd actually be interested in hearing from any of you. In terms of map views, feature searches, our digital accessibility team at the university really has no idea what to do as far as how to handle this kind of data, or it's very difficult to move around a map like that without getting trapped in there. And I think data, but geospatial data especially, in terms of that kind of accessibility, I think there's going to be a lot of changes that are going to come probably sooner than we expect, but that's just something I think is going to grow into this set of principles. That's it. Thank you very much.